Yes. Good morning and warm welcome to all participants, faculty members, research scholars, students, and industry professionals. Welcome to the final day of the online faculty development program on AI and data science in pharmacy education, teaching strategies and practical applications, organized by the Department of Pharmaceutical Analysis, KVSR Siddhartha College of Pharmaceutical Sciences, Vijayawada. Over the past 4 days, we have explored various aspects of artificial intelligence, data science, machine learning, data analytics, and their applications in pharmaceutical sciences. We sincerely thank all the participants for their enthusiastic involvement and continuous support throughout this FDP. Today's schedule involves two exciting sessions. One is by Dr. Prakash Muthudas Garu and Dr. K.S. Soumyarani Garu. These technical sessions will be followed by the valedictory and closing ceremony of the FTP. We are honored to have Dr. Prakash Muthudas sir with us for the first session of the day. Before we begin, I invite Ms. K. Jyoti, Assistant Professor, Department of Pharmaceutical Analysis, to introduce our esteemed resource person and present his biodata. Over to you, ma'am.
Good morning to everyone. It is my privilege to introduce our esteemed resource person for this morning session, Dr. Prakash Muthudas. Dr. Prakash Muthudas is currently serving as the Director and Chief Scientific Officer at A2Z 4.0 Research Analytics Private Limited, Chennai. He is a chartered chemist certified by the Royal Society of Chemistry, United Kingdom, and brings with him more than 20 years of distinguished experience in the pharmaceutical industry, having worked with leading organizations such as AstraZeneca, Sanofi, Dr. Reddy's Laboratories, Smith and Nephew, and Oakhart. Academically, Dr. Muthudas holds a Master of Pharmacy in India, Master of Science in UK, and PhD in UK. He has also completed postgraduate program in business analytics, business intelligence, and artificial intelligence machine learning, along with certification as a Lean Six Sigma Black Belt. His areas of expertise include pharmaceutical sciences, material science, analytical chemistry, statistics, artificial intelligence, machine learning, optical and chemical imaging, and vibrational spectroscopy. He is widely recognized for integrating data science and decision science with pharmaceutical research to solve complex industrial challenges. Dr. Mutta serves as a senior advisor to ICECW and NIT Madras Initiative and as a subject matter expert to the Indian Pharmacopoeia Commission, IPC Ghaziabad. He is also a member of the Board of Studies of several reputed institutions, including Anna University, SSN College, PSC College of Pharmacy, and Welltech University. An accomplished researcher and mentor, he is the author of one patent, more than 15 research publications, and two book chapters. He has trained and mentored over 55,000 students and professionals and has guided numerous institutions in developing industry relevant skills in analytics and AI. We are indeed honored to have such an accomplished scientist, researcher, trainer, and industry expert with us today. We are confident that this session will provide valuable insights into the application of artificial intelligence in pharmaceutical sciences and inspire all participants. Please join me in extending a warm welcome to Dr. Prakash Muthudas. Welcome, sir, and thank you for being with us today. Over to you, Dr. Prakash Muthudas.
Yeah.
Good morning, sir.
Thank you, ma'am. And yeah, thank you. Am I audible?
Yes, sir.
Yeah, it's clear? Perfect.
Yes, sir.
Yeah, thank you. Thank you all, and thank you, ma'am. And it's my sincere apology. Yesterday, I was occupied with some uh, unplanned meeting. I was not able to share with also, but quickly, thank you for Siddhartha College to amend or reschedule my things, and thank you for all the participants for accepting and coming extra time today. Okay, so let's try to see, and I'll try to do due diligence for the activities that we have planned, and let's start without any ado. I'm sharing my screen. Please let know if my screen is visible. Yeah, is my screen visible now? Should be, I think.
Yes, sir. Yes, sir.
Yeah,
It is visible, sir. Yes, sir.
it's visible. Okay, I'm just okay, great, and thank you for the opportunity. And whenever I start thanking with right from my school, college, which had given me the basics and also the foundational to my career where I stand as of now today, and to various companies which had sponsored my PhD, masters, and also various partners who have been making me equipped with latest technologies day in and day out. And thank you for all of them who are being part and parcel of my career now. Thank you all. And then yeah, this one I would like. This is a new one that I thought I'll add it. And yes, you are all aware, right? The B Form NEP 2020 syllabus is now ready, and it's rolled out. And the entire idea of this particular program, I'm just taking the artificial intelligence and machine learning, which is added as part of every semester, so that what is it in it for the university students, for the faculty. That's what I thought I'll prepare one infographic where in the foundational levels from 1 till 6 you start understanding how the data science, how the programming Python is going to help. Initially it is very difficult, I agree that. When, say, like, as you all know, today I stand at the ground of doing a lot of programming and lot of things. But when I started, I was like you. At the age of 37, when I started, I had no idea or no clue of how am I going to progress. But it took a systematic methodological approach of taking programs, practicing. 1 year I spent dedicatedly. Now the efforts of that 1 year I am able to see in return. Uh, in 2017, when every world or every pharma company where I was working was looking around the managerial roles, MBAs, and those kind of things, I thought I will step out and do a data science related activity. Yeah, so that's the big thing, and I'll just try to say how I started understanding this concept. That's how I'm going to take it, and then I will showcase certain applications which, once you understand, becomes much easier to develop, and there is a lot of good things for you all, which I will slowly open up. Yeah, and during this times, I run a monthly, once in 3 months, a program which runs for 12 to 14 weeks, and people get enrolled. The first batch was various people from Guntur in college and Bhimavaram, and that's how I also got in connected through Venkat sir, Siddhartha College. Thank you, ma'am. Yeah, and say, like, today's topic is mostly on AI in various departments. I will try to focus and give on pharmaceutical analysis, formulation, discovery, and clinical pharmacy and pharmacovigilance. We can take it when it is required because of the time constraint. I may not be able to share those applications, but there are a lot of applications around that. Yeah, to start with, the industry is currently, they may say five, but still we will restrict to four. Industry revolutions are bucketed in four things. Since the 1784, when we were doing all manually, then the steam engines were innovated, and that is the time you start having that steam engines and related activities. That's all for the boilers, all those things. That time the mechanical engineering is very important. Slowly in the industry revolution too, when the electricity started coming up, you know, things like how the mechanical activity was converted into electric activity. And in the 1960s or 1970s, automation started popping up. So we can use remote, or we can use sensors that way. But sensors with automation with data analysis is good. So say for example, you can take an example of a room where it is very hot, 34 degrees or 25 degrees is come, and you take a remote, you start each and every time some minusing the values. For example, tonight, yesterday night when I slept, the temperature was so high, I switched on, I forgot to put automation, like means forgot to say like after 2 hours switch it off. I was not sure because it was very warm after 2 hours. Also, I was not very confident that should I switch it off or not, keep a 2 hour time interval. Here, data science, if you say like if it helps, if the sensors are present in the room, say like if the temperature of the room comes down less than 25 degrees, switch off the AC. If it is more than 24 degrees, switch on the AC. These yes or no type can be done in automation, but sensing it in real time cannot be done using automation. This is where the data analysis comes into play. Yeah. So based on data feeded, if the trend is more than three data, more than four data is coming more than 26, then do this activity. If not, do the other activity. This is the just a very basic example of understanding where the data will be used a lot and then taken the decision, right? So that way. And I wanted to start here with a, small story or a narrative, which I always do that. And I want someone to participate if it is okay. Uh, Anyone can participate. There will be one or two questions that way. And this story has happened anywhere in the world, but not in India. And this is how I start with. And this story is more if any of the people have attended my sessions in Guntur, Acharya Nagarjuna University, or Guntur Chalapati, or Bhimavaram. Probably you would have heard of this story. Uh, but still, if you can remember, I'm okay. If you can answer, that's also fine. I don't want you to stop away that you already know the answer. Okay. So here, what happened was this starts with the Walmart BD story, where 6 years of sales data was taken up, and the activity of the data science team along with the supervisor was to understand how we can increase the sales and how we can make new combination of products or something like that, and then we can do it. So for this, they took 6 years of data. Okay. Usually, whenever we do in combinations, when we wanted to sell products in combinations, what are the combinations we give? Any idea? So, say like usually one of my combination is say like shampoo, shampoo and soap. Shampoo plus soap can sell in more. Is that fine? Any other combination people can think about? Anyone is speaking? I am not able to hear.
Yes, sir. Is it audible, sir?
Yes, ma'am. Yes, ma'am. So any other combination, if anyone can remember, it will be great.
Sir, shampoo and conditioner, sir.
Shampoo and conditioner, someone has given bread and jam. Excellent,
Milk
ma'am.
and tea powder. Milk and tea powder.
Milk and tea powder. Milk and tea powder. Great. Yeah.
Bread and eggs.
Sorry?
Sir, bread and eggs.
Bread and
Eggs.
cheese or eggs? I did not.
Yes, sir.
Bread and cheese. Okay. Bread and jam, bread and cheese. Okay. Great. Bindi with any other combination? home, for example. Anything else? Something like the painkillers and the antacids. Okay, okay. Let's say Walmart. Okay, still we can go with it. Not a concern. We will have three more answers and then we will look into something. Couple of more.
McD offers is there no sir burger with
Okay,
cheese.
okay. But okay, this is a Walmart, right? Like something like detergent and fabric conditioner. Excellent. The Walmart is something like your supermarket. That way, but still we will consider burger with fries. Why not? If they have any cafe in the Walmart, yes, why not? But let's stick to Walmart or the superstore. Fabric and detergent is another area. Yes, paper, pencil, paper plus pencil because you have stationaries as well there. Any more? Yeah, snacks with tea. Yes, excellent. So when this is in general, this is what we know, right? We have come across, we have seen it, and that way. But when the data was book and the pen, excellent. Thank you, sir. So what happened was when the data was taken and when the data was analyzed, the data scientist and the supervisor were got very what do you say? Very surprised to see there was a combination of product that was selling high in combination. Beer and the diaper. That's what the B and B story means. So beer and diaper were selling in lot in combination. Could anyone think can this sell? We spoke right just now. You can chat, give answers in the chat as well. Yes or no. That's also fine. Did you expect this can give a combination cell? No, no. Many of them are saying no. Couple of them. Any more? No, right? No, no. Excellent. Excellent. Yes. Okay, that's one way good for me. Yes, because I was also never thought this could be in combination can sell a lot. But if you want to give a reason, you have seen the answer, or we have seen the answer. Do you want to give a try of why this could sell more? Can we have a wild guess why this combination should sell more? We are seeing an answer. Now immediately our brain has to work why this could happen. No similarity in use. Okay. What do you mean? I cannot understand, ma'am. Are you saying this combination cannot sell or it cannot uh, sell more or how is it like? Lavanya, ma'am. Thank you. Maybe yes. Otherwise, story would. Okay, that's fine. That's nice. That's nice. Okay. If yeah, I think if there can be another. So I assumed, or I whenever this results got, I started thinking weirdly if this can happen. If anyone thought like me, you can give just like a thumbs up. If no one had thought like this, you can give thumbs down. That will be excellent. Okay, did anyone think like this? Yeah. Hold on. Okay. Did anyone think like me? I started thinking like no, nobody had thought. Right? Anyone else? You can give thumbs down or thumbs up? So this we call it as assumption. So there is some results coming and we started assuming certain things. This we call it as killing the results because yeah, we can say yes, you are right in a way. Uh, Say, like for example, this particular combination was selling more during the weekends, and when some results we get, immediately we assume certain things that cannot exist, and we say this cannot happen, and we throw away. Like I'm not sure about others, but in Tamil Nadu, when TVK had started the party and Mr. CM, the current CM Vijay was contesting the election, all other 70 years old parties assumed that it's not going to have an impact because other people in the past have failed. He will also fail, but their assumptions did not work. It went the other way, right? So we cannot assume certain things and leave it until we acted and we have enough of results. So in this scenario, what happened was the sales person and the supervisor decided to have a kind of a questionnaire kept in place, and if anybody picks this combination, they wanted to question. And when they questioned, they said they have a booze in the evening and or during the long weekends. And when they buy this beer and when they are coming, these are newly married couples and they have young kids. So when the diaper is not there, you know what kind of messy things go around. And if it is a party along with few other friends, lot of kids come in, and if there are no diapers, what happens? So what this young couples with kids decided was whenever we take a case of beer, we take one case or two case or three packs of pampers as well, diapers, so that uh, the party will not get killed or the party will not get odd enough or something like that. So it will not, we will not get disturbed because of anyone using a lack of diaper or something like that. So the did data analysis derive new results or something like that? No. What we are trying to say is when we are digging around the results properly in a proper fashion with a lot of tools, we start to see things that are hidden in the original data, for which humans would have assumed and gone with the traditional way of analysis, and assuming most of the people who have published taking those results and we go. But if you do a data analysis, some results become more sometimes weird, and if you start digging around, it becomes much easier. Recently, we were working with UV spectroscopy data, and we saw one particular wavelength was decreasing in intensity as a function of concentration. But as per Beer's Lambert's law, this cannot exist. But we are trying to understand why. And these results are in reproducibility, it is coming. So it can end up for us in a new concept that is going to make the paper a worthy paper that I'm working, and I will show you a little result around that. Yeah. So these kind of analysis, these kind of results gives us a very big impact. Especially, is this new to us? No, Netflix. This person, if has seen the movie, also seen this movie. Amazon. If a person bought this item, also bought this item. Okay, when this combination, weird combination comes in, and we say maybe this is important to us. We buy it, right? That's called as retail analytics. So that's how the quickly data science is there. And data is now, it's not only in pharma or not only retail, everywhere we have the data. And now we call data as a oil. And even in education sector, the data is more. We can start understanding, and people use this for digital marketing and all those things. Yeah. So when we wanted to speak, we bucketed the entire data science world or thing in three different terms: artificial intelligence, machine learning, and deep learning. And artificial intelligence is a bigger bucket. I'll just derive those things later. Then we also need to see the concepts like data science, data analytics, data mining, and this is how it gets connected with various other fields. Okay. One thing that we have to understand is three major things makes this domain important. Which which application or which sector we are going to look. For example, pharma, the mathematics and statistics, the computer science is going to be common. Okay, only the domains change. Pharma, healthcare, Ayurveda, food, for example, in the previous thing. Computer science and mathematics and statistics are going to remain the same. And we do not want to invent the architecture of the algorithms that the computer science people will take care. We are just going to be users, something similar to statistics. We only use ANOVA t-test, Krustal values test, and similar man-Whitney test, all those things. We don't derive the mathematics or statistics around that. Okay, we are more application-oriented people, and the domains change in that way. Okay, till here, any questions? We will quickly get into how we will understand the data science world. Any questions till here? Good to go. You can give thumbs up, or if you have questions, you can type in. Yeah. Oh, great. Okay. So I believe we would have come across all these kind of terms, and I was also get stuck here. How am I going to understand these jargons? So what I did was in 2017, I just took the entire terminologies and I split it into three buckets. What is the core areas, and what is the processes and the methods? What are the workflow elements that are required to achieve this thing? It comes in reverse. The workflow elements, then how we fit in the process, and then the area or the domain that comes out, or the terminologies that comes out. So when we define this data, features, prediction, all those get into the horizontals. Yeah. So then now how they are getting connected. So from the data, we understand features. For example, when we saw the beer and the diaper story, that is a data. Then you have in the say like beer as one component, diaper as another component, pickle, jam, bread, all other things are all one component. Okay. So in the pharma field, if you see, our dissolution is the thing. The data consists of UV spectroscopy, UV spectra followed by dissolution. So UV spectra and the dissolution becomes the entire data. Yeah, what is the features? UV spectra becomes the features. And then from there, the spectra is increasing as a function of concentration becomes insights. What are we predicting? Dissolution. And the dissolution results are pass or fail. That's the action. Yeah. So that's how we are connecting it. Then from here, if you see, are we doing for the UV spectroscopy data normalization, derivatization? That becomes data transformation. In all the other data also something like this happens. That's the data transformation. Then becomes your, are we going to use principal component analysis, cluster analysis, or linear regression, or partial least squares? Partial least squares, linear regression become your supervised learning. Supervised learning. The PCA cluster analysis become unsupervised learning. From this, what am I going to do? So in this segment, if you see data transformation you are doing, and then you are going for prediction, means we are doing as a human data transformation, and then we are taking. But in deep learning, what happens is you just give the data, it does all the transformation on its own and gives the prediction results. I'm not getting deep into it, but it is bypassing all the other steps, and it's directly going for the, from the data you get the prediction. So there is a way how it does, but that if you want to understand in detail, we can discuss that later on, but not in this thing. But you can ask me as a question, I can share that in the last few minutes. And then you do this entire segment becomes the machine learning, and then you get from here the data and you get insight that becomes analytics. And if you add machine learning plus analytics or insights, that becomes the data science. If after all doing all those things, if the decision is taken still manually with human, it still retains the human decision. But if it is automatically taken, that remains the artificial intelligence. So in ChatGPT, deep learning models are used, large language models are used. It gives results on its own. That's why we call that as a artificial intelligence tool, AI tool. Any questions here? Till here? If it's unclear, we can say we can re-discuss certain concepts, or if you are to move forward, we can move forward means you can give a thumbs up. Yeah. So couple of more thumbs up can help in understanding a sample representative of the population. Couple of more thumbs ups. Thank you all. Okay, great. Yeah. So in the next section now, quickly, if you want to say like, I'm not going to ask you a question, but I'll tell you can reflect on yourself. When we are going to have a problem in our hand, which is mimicking 3 into 3, that becomes, we can easily do using our memory. It's a multiplication problem, and the results are going to be 9. If it is 5 into 5, 25. If it is 65 into 65, maybe we are finding difficult with our memory. Some people can do Vedic mathematics or more abacus kind of thing. They can get answers, but still here the tool that will be required, we may have difficulty in memory, but we have to get into a tool like calculator or a pen and a paper. But if you want to do 10, 20 calculations and 30 calculations, and sometimes we want to keep what was yesterday, what was day before yesterday, writing in a paper and a pen and documenting it is going to be tedious. And if you want to calculate from there additionally, it becomes more of a problem. So what was becoming advantageous than the memory now becomes disadvantage for some other context. So that's when we get into Excel and Power BI. So in the Excel, we can do a lot of data, you can do millions of cells, all those things. But based on 10 years data, can I predict the new incoming data? I have a difficulty. Or lot of data cannot be handled by Excel in itself, or predictive analytics cannot be done. This is where the AI, where the predictive analytics, prescriptive analytics, Python programming all comes into play. Okay. So in a glance quickly, and then what we do with the AI, mostly 4 activities is what the AI is going to do, or the machine learning or the deep learning or whatever algorithm we are developing is going to do. Either we are going to learn new things, or something is there we want to reason why this has happened. We can do decision making and problem solving activities. More or less, all the things have been bucketed into these 4. Why we wanted AI. Excel may have a risk in certain things, because most of the times we say Excel is hindsight data, or we can only collect the data, understand what has happened, what has led to the problem, but what should we do with this? It's always difficult. That's where we get into advanced data analytics. So usually I try to see like a kind of a blueprint for the artificial intelligence and machine learning. It's a 12-step workflow, split it into 4 phases. Usually in these 4 phases, what we start doing is in the foundation. We try to understand what is the problem. Do we have the data, or should we collect the data? The collected data or the data in hand, can we understand more? Yeah. So for these stages, we can use sample representativeness, statistics, all those things. We need to understand what is the data type, whether it is a qualitative data or a quantitative data, whether the data in hand is discrete data or continuous data, all those things. Okay, and then we do little bit of correlation analysis, then descriptive statistics like mean, median, mode, standard deviation, skewness understanding, bar charts, histograms. These all we teach in the course in detail how we can understand when to use which graph and all. But because of time for 45 minutes, I just need to move little ahead. So I'm just giving you a brief idea. Okay, then data cleaning. If the data is, say, for example, the contest is going to be boxing, and here should we have the children boxing with adults? That's not right. It's a unnormalized data, meaning the weight, the body mass index of the children and the adult are going to be different. And definitely, we know the answer is only adults will win against the children and men and the women. If this game is left out with men and the women, who wins? We know. And similarly, the task that is highly proficient for the women, and we include men into it. Obviously, we know there is no normalization. So the data normalization is done. Certain algorithms fix the number, height, and all. So because of which we need to clean and fix. Feature engineering, especially taking the example of UV spectra, we should know which peak is going to be representative of the components. Yeah, that we call it as feature engineering. Exploratory data analysis now is how they are each all connected with each other, and there are a lot of other algorithms that we use. Then we get into this is usually in the statistics. If you have been doing statistics, train test split is nothing but you are having a sample data and the test is a validation data. But in the machine learning, what we do is the data that is already in our hand. If you have 50 data, it will be split in a proportion of 80-20. 80% will be used for training and 20% will be used for testing. So that we know whether this model will work or not. We will not wait for new data to come in. So we already, and then we will see whether the new data is going to be, is this model sufficient to understand the new data or not? That we call as method transfer. And then lot of if the data are not good and if the results are bad, then we get into data pre-processing, model building, model evaluation, and model interpretation is new area which in the statistical way we call it as post ad hoc analysis, but model interpretation is helping a lot when we say black box. Many times machine learning, deep learning are called as black box. You put the data, you get the results. Why these results have come, we don't know, but I'll just try to show you. Decision support is how, what are the things that can help us in decision support. Decision support in itself is a life cycle management of entire model. Yeah, so each can be taken in discussion, but due to time, I'll just this is what I generally do. And one thing is over here is this is how the data interpretation. Once you do the model analysis, post modeling, we get such kind of results. Why the model thinks this particular feature as being considered important and how it is related to the data. And I'll just give you one example which you can understand in detail. Yeah. And is anyone interested in this particular understanding anti-cancer ligand prediction? Will this be useful? Anybody from chemistry? If not, I can skip this and go to for pharmaceutical analysis and the formulation. Yeah, it's helpful. It will be useful. Okay, great. Then in that case, we will just go in, and this is a reproduction, reproducing the paper and understanding. Can we also do similar analysis using our coding expertise and things? And this is the reference is kept over here. And what these guys have done is they have taken 5,000 anti-cancer data and 5,000 non-anti-cancer drugs data, and they took a similarity indexing and they split it into training and splitting. They do lot of models. These are called random forest, decision trees, like that. But we can take these things in deep later on. And then they developed a model. How they have brought over years is whatever steps we did: data collection, feature extraction, model training, model valuation and validation, prediction method. Okay, and you have libraries, all those things. And what this came back telling to us is the models, these models, they like gradient boosting method is really good. And what did it say importantly is we have to see why I'm saying this model explainability and interpretation is important is here, because in the RD kit you get lot of parameters that are designated to the drug when you make it into fragments or all those things. You get lot of parameters like LPC, SP1, N bonds, all those parameters. Of this, which is helping to predict whether the synthesized chemical is an anti-cancer property or not. Okay, that's the thing. So here, what is this feature value is whether the synthesized molecule or the studied molecule is having anti-cancer activity or no. So low means no anti-cancer, no cancer activity. High means there is anti-cancer activity. This is the first thing that we have to see in this Shapley additive explanations. Second thing what we have to see is what is on our y-axis. What are the parameters or what are the features that are present on the y-axis. The third one that we have to see is the x-axis, which are sharp value. The sharp value, if you, I'll just slightly zoom in, it goes from middle value is 0, goes negative and then goes positive. Yeah. Now we have to see the fourth and the fifth. If the pink color, which is high on your right scale or the color scale, is pink value is falling on the positive side, means pink is high value and falling on the positive side. It means this particular feature has a direct impact on the anti-cancer. If it goes opposite, blue means low value and it is falling on the right side, and pink means high value and falling on the negative, means it's having a indirect effect. Let's, you follow me for next 2 seconds what I'm going to interpret. The LPC is higher the value of LPC, the product is having anti-cancer property. Lower the value of LPC, the drug is having less anti-cancer property. MR low. Higher the MR value, the anti-cancer is low. Lower the MR value, anti-cancer is high. How many of you understood the interpretation? Yeah. Okay. So that's the here we have done, although it's going to take little time and understanding all those things, but quickly I'm just trying to make you aware of how things are moving and how advanced are there, and say like once you develop these libraries, you can just synthesize your molecules in your lab, plug into this software, and you can now start predicting whether there is anti-cancer property or not. When you get an anti-cancer property probability more than 0.6, you can now start testing for other practical impacts like SSNMR, or you can go into toxicity studies, all those kind of things. So your cost and money is saved before. So the prediction helps you there. Yeah, and also it can help you in lot of other things also. Okay, so in statistical terms, it's called causation. IPC, it's positive, is in red side, high value is red, direct relationship to anti-cancer activity, like that we are interpreting. Yeah, even SP1 is opposite in relationship. So if this can make you sense, it's great. So next thing is getting into the formulation. in the formulation, if you are aware, there are these many unit operations. Is formulation pharmaceutics going to be helpful if you are going to go through this example? If few people can show their thumbs up, or I can skip. If no pharmaceutics department, I can move to the next example. Are there any pharmaceutics example department? Okay, thanks. So even one person, if raises the hand, we should appreciate that. Yes. So in the manufacturing process, if you say like you have a lot of unit operations, right, from dispensing the chemicals, blending them, granulating, drying, milling, lubricating, tableting, coating, and then becomes your tablet. If the steps directly from blending, you go to lubrication, it becomes direct compression. Some drugs are very good for to be directly compressed, but some are not. So some are heat sensitive, some are moisture sensitive. For moisture sensitive, we avoid the drying and the heating steps and get directly into dry granulation. And if the drug is really good, no moisture sensitivity, and but it is fluffy like cotton it is there, we go to the entire steps and we go and make the wet granulated tablets. Like this, then based on machines, we have lot of parameters, and then we get these kind of data. So what are the material related information like API, lot size, particle size, magnesium stearate, supplier, all those information we have. Then process related information like how the milling is done, screen size, blending time, blend speed, all those things. And one of the major reason to mimic how the tablet will act in the body is dissolution test. If it gets it dissolved at a predetermined time in the pH 2.1 or 4.5 or 6.8, it becomes more comparable to the body, and we can go for clinical trials directly. Yeah, if it passes here. But can we start predicting certain things, whether it will pass or fail? How are we going to change the parameters? Because when there are more than 18 parameters, human cannot simulate all the things and give a conclusion. We cannot do more than 2 or 3 parameter correlation. That's human's limitation. This is where we rely on the data analysis, where the computers can do more than 100 dimensions, more than 1,000 dimensions. Yeah. So when we did that, okay, we got uh, results of the model saying that at 2% error, I can predict the dissolution uh, percentage the drug will release based on if you change the parameters or change the lot of the API or all those things. But more than the results, I wanted to get into the interpretation. In the interpretation, what one of the things is saying is the spray rate, the mill time, the screen size 5, coating viscosity, blend time are all the parameters that are very much impacting the dissolution properties. And again, coming here, first you have to take the scale. Low means low dissolution, high means high dissolution. And y-axis, we have to see all the features, and x-axis, negative, the positive. If the red is on the positive side, mill time. What we will say, milling time is having a direct impact on the dissolution. Yeah. So if we do more milling, more dissolution. What does that indirectly mean? If the milling time is more, the particle size is getting reduced. Lower the particle size, faster the dissolution. Is that fine? The connection? Hello? Yeah. And then connecting the same mill size with screen size file. Screen size is, say, like for example, bigger the screens means bigger particles go down. Smaller the screen means only small particles will go down. Now this will have a indirect relationship, meaning screen more bigger the screen, lower the dissolution. Smaller the screen, higher the dissolution, because it's going to allow the particle size differently. So mill time and screen size are indirectly proportional in itself. So they are going to have similar relationship with the dissolution. So these kind of conclusions can be brought. But these are some time we spend understand how the models develop. But what am I trying to show here is you would have gone through all the 4 days of session. Lot of AAML can be done. I'm trying to show in real time how this is helping so that you can create a um, interest and say like we can do a lot of work, lot of publications and all those things. I have at least had 6 publications in this area, and the next one that I'm going to the next one that yes I can share the PowerPoint. Yes, yes, Dr. Lavanya. Do you want to unmute and ask the question, or you're okay? So if I have to answer this thing to you, your question, Dr. Lavanya has asked the question is, when the prediction is done on the activity of molecule, what is the need for clinical trial? Okay. Uh, we do clinical trials to demonstrate safety, efficacy. Clinical trials are done to demonstrate to the regulatory bodies on the safety, efficacy, quality of medicine. Okay, so what activity we are predicting here is a part of efficacy. Okay, we are only doing here efficacy. Even we can predict based on whether it is going to be safe. If I follow this method, I can predict whether it can be quality. What we are trying to do here is, instead of spending 14 years of time doing this entirely experimental, we are reducing that time by predicting. If I follow these things, I can ensure safety, efficacy, quality will be there. In 2 years, I can show the practical examples, and then I can directly go and do the clinical trials. If the clinical trials without practical results, without clinical trials, the regulatory agency is not going to accept it. Okay, what we are doing here is we are reducing the timeline, and we are reducing the cost, and we are reducing the failure. Okay, the cost of failures, the cost of time, and the cost of resource of human is going to be huge. One clinical trial failure is going to cost 2 crores of minimum. Okay, one batch failure in the lab, one experimental failure of formulation is going to cost us around 20 lakhs. One experiment of analytical method being wrongly developed is again going to cost us 10 to 15 lakhs. This is per test I'm saying. So if I'm going to do 3 tests wrong, 4 tests wrong, and 2 clinical trials wrong, you know the amount of cost that is involved, right? That is the only thing that we are bringing it down. Okay, so that you can have lot of profits, and you become the uh, you now become the first to file. All those things. Okay. If I have answered your question, if not, you can let me know things. Yeah. I have. Okay. I just get into the final thing. Eco-friendly, where this is a public. This may be very interesting for every one of you because we are taking the published results and we are going to do some additional work around it. So no experiments, but a new paper. We already have done 3 papers from already published data for near infrared spectroscopy, but that would be little difficult, or I had to give what is near infrared, all those things. I did not take that example. We are trying to do the same with UV spectroscopy data. I have requested Sitaraman sir, SRM and data we have got, and we are working around it. And in this, if you say like paracetamol, aciclofenac, and epirosone are the APIs, and they have did a lot of work around the principal component regression and PLS and the univariate calibration. The paper is awesome, and it is published in Processes, and they have done it for the green evaluation. What we are trying to do is whether this separation can be understood by a conventional principal component analysis, because if you do a principal component analysis, we this is still under preparation, but I will show you advanced methodologies where, as a function of concentration, calibration curve, this is on your on your color scale, it's a calibration. If you can see it immediately, paracetamol concentration from 12 milligram per ml to 18 milligram per ml. So the calibration curve has at least 5 into 5, 25 data, around 30 data, 1, 2, 3, 4, 5, yeah, around 25 to 30 data. In the conventional data analysis, are you able to see any kind of a separation between the concentrations? Say like blue is here, blue is here, blue is here, red is here, red is here, red is here, red is here, everywhere it is there. But we have used now, yeah, this is the same with all the components, be it epirosone, be it aciclofenac, or be it anything. But here you see a bit of separation from this side. But if you see the advanced programming that we are developing, you see separation of paracetamol based on ingredients in this space. You see, the yellow is high concentration and the pink is low, means high concentration, low concentration and high concentration. You see a lot of separation, better separation is coming. Based on this, now we are going to build our calibration curves. And aciclofenac in the same space, we are able to distinguish vertically. And this is epirosone, which is even more better separated. So what we are trying to do is bring in a concept of separation science that we do in HPLC, similar concept using data science for principal component analysis, and then try to then develop the regression model. This is still under progress, and we are trying to publish it in another 1 month along with the first batch of students. When we are doing the course, the major thing is we have to publish a paper at the end of the course with all people support, who can write, who can do analysis, all those things. Yeah. And one thing that we don't get with principal component analysis is the interpretation of the data, what is there. If you say like in the first principal factor analysis, you see it is separated by this wave numbers, these wave numbers and these wave numbers. We are doing more interpretation to whether these peaks are associated with paracetamol, epirosone, and aciclofenac, and we will get more details around that. So, for example, AI is not going to replace the researchers; it's going to help you in your data science, and there is a lot of work. And we run programs at various levels, literacy till advanced applications, where you can publish a paper, awareness program for 4 hours, 2 weeks program, and a 16 weeks program. 16 weeks program is where we get into the scientists and the faculty will work along and publish a paper along with it. And for that program, we only take 4 to 5 faculties, not more. Yeah.
Sorry for the disturbance, sir. Sorry for the inconvenience.
I'm done. And,
Yeah, sorry.
Forgot to give my.
Yeah, your session is interesting with connective examples,
Yeah, yeah.
but due to time constraint, we need to end the session.
Yes, I'll send the QR code soon, and I forgot to prepare that as well. You can get me the
Sure.
QR code.
As we are from Department of Analysis, we want to connect with that chemometric methods. Again, we'll connect with that session, sir.
Yeah, I'll share the slides after trimming. to so that some people have asked.
Sure. And thank you so much.
Thank you. Yeah.
Oh, please.
I was just to finish. I just wanted to also touch with the
Yes, please go ahead.
advertisement of the course. That's fine. I'm done. Thank you, ma'am.
Okay. Thank
Thank you
you.
all.
Thank you so much.
I'll leave the program, right?
Yeah, already another session speaker has been joined.
Yeah. Thank you.
Yeah. Thank you so much. And sorry for the inconvenience.
No, no, no. I'm fine. I'm fine.
Yeah, yeah. Good. Thank you, sir.
Thank you, sir, for your wonderful session. Now it's my privilege to introduce our esteemed resource person for today's another session, Dr. K.S. Soumya Rani Garu. Dr. K. Soumya Rani is a distinguished founder, editor, reviewer, speaker, and trainer with extensive expertise in scientific writing, research communication, artificial intelligence applications in research, and higher education. She has more than 7 years of experience as a speaker and trainer and has delivered expert sessions at several prestigious institutions, including IIT Madras, IIT Delhi, IIT Hyderabad, IIT Guwahati, NIT Delhi, NIT Warangal, IIT UNA, VIT Vellore, etc. As an accomplished academic editor, she has edited more than 1,500 scientific documents, including research articles, review papers, thesis, grant applications, annual reports, science communication contents, and all. She has also been recognized as an expert editor in biochemistry, genetics, and molecular biology through her association with leading scientific editing organizations. Academically, she holds a PhD in plant biotechnology, jointly associated with Bharatiya University Coimbatore and the University of Osnabrück, Germany. She is also a recipient of several prestigious fellowships, including the DAAD Scholarship from Germany, CSIR Junior Research Fellowship, and JNCASR Summer Research Fellowships at IIT Madras. Her areas of expertise include AI for scientific writing, AI tools for research, AI in higher education, ethical use of artificial intelligence, science communication, research publishing, and career development in life sciences. Through her training programs, she has empowered researchers, faculty members, students to effectively integrate AI into research and academic writing while maintaining ethical and scientific rigor. We are indeed honored to have such an accomplished researcher, editor, entrepreneur, and trainer with us today. We are confident that her session on generative AI, scientific writing, and teaching methodologies will provide valuable insights and practical strategies for us all. Please join me in extending a warm welcome to Dr. K.S. Soumya Rani Garu. Welcome, ma'am, and the platform is all yours today.
Thank you, Professor. So just give me a moment. Good morning, everyone. Or yeah, still it's good morning. Just give me a moment. So I hope my screen is visible and I'm audible enough.
Yes, yes, ma'am.
All good? Okay, great. So good morning once again. And this is a question I have been asking across platforms, online, offline, for the past 3.5 years at least, I would say. Yeah, three years at least, right? So how many of you here recognize the face that you see on the screen? And normally, if you sat with me in an offline class, I would tell you this is important because this face happens to be that of my favorite actor, one of my favorite people ever to have walked on the earth, I would say. And usually, the right answer is you must recognize him as Doctor Strange. Some of you might recognize him as Sherlock Holmes. Some of you might also recognize him from some of his amazing other projects as well. And one of the really nice projects that Ben did is called The Imitation Game. So this is a movie that is set in the World War times, World War II to be precise. This was a time when the Nazis, the Germans, they had a clear upper hand. They were winning the war for a lot many reasons. One of the key reasons was that they had a technological advancement or technological advantage, I would say, in the form of an encryption machine called Enigma. So this machine could encrypt messages sent from the German army base to every nook and corner where the German troops were fighting. And this code was thought to be unbreakable. And this gave them a huge advantage, and the Allies were really struggling to find a way to bring down the German force. It is in this background that an amazing English mathematician, a supercomputer nerd, and a person who did not have a really easy life, I would say, Alan Turing, walks into the war scene, and he goes on to break the code of Enigma. And this achievement by Alan Turing and their team leads to the downfall of the Nazis and eventually brings the World War II to an end. Today, 6 decades after the World War, we are still talking about Turing. Not because he just broke the Nazi code, that was a huge milestone, but also because he laid the foundations of what we today assume as the brand new technology called artificial intelligence. Turing, I'm sure even if you have not heard his full name, you would have heard about the Turing's law of AI and robotics. And it is the same Turing that we are talking about here. So, why exactly are we opening this session here? Simply because these years were the formative years for artificial intelligence, not just the generative AI we are talking about, but AI as a whole, as a technology at large, started somewhere around the World War times. And Alan Turing definitely played a huge role, which earned him the name of one of the fathers of artificial intelligence. And the story that started 6 decades ago, a story that not many of us knew, most of us coming from, say, life sciences background, medical backgrounds. I come from biotechnology myself, and AI was not an everyday conversation. Today, every layman you meet can talk about AI. You go into a social gathering, there are a group of people who are cosily seated in a corner talking about the pros and cons of AI and how AI is affecting the economy, how IT jobs are being lost to AI and whatnot. That is how pervasive AI has become, not the original technology that was envisaged, but this new form of AI called generative AI or Gen AI, as we have come to call it lovingly in the past 3+ years, has definitely changed our lives forever. So, what happened? When did it happen? We all do remember November 2022, just that we did not know it is going to be such a huge pivot, such a huge conversation starter back then. Maybe a friend or a colleague walked to your desk and then they talked about this new kind of a tool which was much better than Google, where you can ask any question and this tool seemed to have really nice answers, and it was very, very easy, much better than Google. That's how most of us got introduced to ChatGPT. And then we learned the names OpenAI, Sam Altman, and then we had an entire barrage of tools thrown at us, and our lives have changed for the better or for the worse is highly debatable even today, I would say. ChatGPT was just the beginning, and slowly over the months, a lot many other companies, other players started fraying into this arena of Gen AI. And one very clear difference or an upgrade was the introduction of reasoning models like DeepSeek, for instance. Because when ChatGPT walked into our lives and started giving answers, the first week we were all impressed because, wow, this can give me answers to almost anything. And that did feel nice. And then 2 weeks, 3 weeks into the journey, what we realized was that yes, this tool does give me answers, but it is not always accurate. It is not always comprehensive. And I have no idea where all these answers are coming from. So, where are these details? Where are the processes? At least few months down the lane, most of us started questioning this. And that is where these reasoning models started getting an upper hand. And especially DeepSeek coming from China soil did gain a huge attention. It kind of created an uproar in the AI world and beyond as well. And even the wave of DeepSeek did come to pass, because in the next few months or so, we moved into the next wave of AI, the next new shiny thing in the AI world called agentic AI, with the introduction of GPT-5 and all of its counterparts and so on. Now, the introduction of agentic AI is kind of touted as one of our concrete steps towards autonomous AI. So, with the agentic AI, what has changed is that you no longer need human intervention at every single stage. You give the instruction or your requirement for a much overarching process and say this process has around 10 steps. You don't have to sit down and describe every single step. As has to be done with the traditional Gen AI models that came out 2, 3 years or so ago, or at least 1 year ago. But with agentic AI, now you can design these tools to perform complex tasks, which can have tens of different steps. And without any human intervention, the tool is capable of operating on its own and getting the desired result. Now, this lack of need for human intervention and the possibility to take over much larger processes, multi-step processes, is what makes agentic AI pretty popular. And this does have implications in pharmaceutical research as well, where there are multiple steps, multi-step processes in discovery, in validation, and whatnot. Throughout these processes, agentic AI could oversee these processes, could control these processes at some point. Though I believe not many companies have tried outsourcing the entire process as of now. But despite having these advancements in models, even with the latest of agentic AI tools, we still face the limitation of hallucinations. Hallucinations is when a tool goes beyond what it knows, goes beyond its test data, or rather misrepresents its test data to create combinations of words. Because at the end of the day, LLM suggest probability machines, and then they create clusters of text, clusters of images, or any kind of output that appears to be true, but it is not really true. These are what we call hallucinations. Hallucinations are a huge handicap when it comes to using generative AI, especially in a field that is as sensitive as research or even in teaching, I would say. These tools still have not overcome the hallucination problem or the roadblock, and that should make us pause a bit. It is all nice to be talking about the great things AI can do, but without understanding the limitations, I think we are at a huge disadvantage. And the first limitation that we can never really erase off are hallucinations. The second limitation with these LLMs is that LLMs have language in their name, but that is all where the language stays. In practice, in reality, LLMs don't understand language. They don't understand your question. They don't understand the answer they are throwing at you, but they're really good with probability calculations. That is why LLMs have made a huge share of entry into fields that are mathematically heavy, like astronomy, for instance. Recently, there was a paper out on science or so. Was it Nature or Science? I'm not sure, but recent weeks saw a paper which claims that astronomers are slowly losing their hold over the field. They feel there is not much humans can contribute when it comes to solving these mathematical issues, because AI tends to do mathematical solving much better than what humans have done over centuries. But then when it comes to creative fields, the LLMs are not really welcome as much as humans are, I would say, at least in some niche areas. So, depending on what field you are in and where you want to use these LLMs, and how important is understanding language and the nuances of creativity, for instance, your limitations around this LLM model that does not understand but just works on probability can be interpreted in different ways, I would say. Now, imagine when I set you to this task. Say we are sitting on an offline classroom, and then I set you on this task of drawing these very simple things that you see on the screen. No matter which part of the country, not even the country, I have done this exercise with cohorts, with faculty members, researchers across the globe as well. And even when they come from different fields, even when they come from different geographical regions, when you talk about a tree, there is a generic image of a tree, there is a generic image of a mountain. And these are called biases. Despite knowing the real world, we have imbibed these certain characteristics of certain things from what we were taught in a very young age. So when I say a house has to have a square with a triangle sitting on top with two windows and one door. When I say a tree, it's usually a curved trunk and the fluffy cotton canopy that we are so used to drawing. And this is sometimes problematic, because real world has to be reflected in how you try to present it. And even as adults, we don't always present the real world appropriately. Now imagine these language models, or these Gen AI tools, as we would like to call them, they are highly biased. Not because they are built to be biased, but because they rest on data, on test data that has bias inbuilt into it. And this is problematic in research as well as in education. Today, AI is everywhere. Any field you talk about, AI has a role. Gen AI has found its way, has found an application one way or the other into multiple fields that we know of. But the problem is, we have not really come up with clear systems to validate how should we approach it. How do I validate a tool? How do I know if a tool is good enough to be used? I cannot judge a tool based on a few outputs that it gives, because validation involves many more steps, involves many more criteria. And at least now, a good AI tool to be used for research or for education should rest on these five pillars. First is transparency. Transparency on who is behind the tool, the company, the money, where exactly the money is coming for developing the tool, for the test data, and so on. If the money trail is not clear, then maybe the tool is slightly sketchy. I wouldn't want to use it. And are these tools using legitimate legal sources as test data to train the models? Even with ChatGPT, there are accusations on ChatGPT using prohibited data that has been prohibited for use by humans, were sourced and used for training these earlier models, which still remains a huge contention. So I would also ask myself before investing in a tool, maybe not as an individual, because an individual subscription is not going to make a huge dent. But as an institution, when I decide I'm going to use AI for my institution, I would also look at the history of the company. I would also look at where the data is coming from, where the test data is actually coming from, to make sure that I am on the legal side of things in using these AI tools. Accuracy would be the third pillar, because I might not expect 100% accuracy, considering that AI tools are known to have certain inaccuracies built into them. But is there at least a reasonable amount of accuracy in the information that it provides in whatever I get out of this tool? Then comes the pillar of data privacy. Will my data be safe if I hand it over into this tool? Do these companies or the tools, do they have explicit data policies that I can verify and also trust? And then comes trustworthiness, where trustworthiness builds only when there is a certain amount of transparency in how the tool actually works. The tool cannot be a black box. It cannot say that, okay, come throw in these questions into me, come throw in this raw data into me, and I will give you the output, without ever telling you how exactly I worked upon arriving at this output, which might not be really acceptable. Even after 3 years, after what feels like decades in technological development, even today, Gen AI is not the magic wand that it was made out to be. It still remains a mirror, a pretty faithful mirror. And for this mirror to really work, for it to give you quality outputs, it's important that you're given quality inputs. And this is where, even with the most advanced models, prompt engineering becomes really important. And prompt engineering is not always about having your fancy prompts. It is not about having 100 prompts, because there is no perfect prompt in the real world scenario. Prompting is always a game of pivoting, which means you are going to submit a prompt, maybe a very simple RTF prompt, where you describe the tool, describe the task, describe the framework. Say, for instance, I am a teacher working in a CBSE school, trying to teach photosynthesis to my grade 6 students. I would design a prompt that just mentions these things. So I need information on photosynthesis as a grade 6 biology teacher trying to teach this topic for the first time in a CBSE setup under a CBSE curriculum. And then I want definitions, I want explanations, I want maybe illustrations, and also I need analogies and examples that these kids can understand. And then, if possible, maybe cross verify the information across 3 or 4 different sources. And if I have certain sources that the tool has to use, say, for instance, I want the tool to pick up information and extrapolate only from that available on the official book, I just have to mention this, upload the resources, and that prompt is good enough to generate an entire lesson plan, classroom content, and also ideas for small assignments I can set these students on, and even a question paper and the rubrics for evaluation and whatnot. So prompting can turn a very simple tool into a powerful assistant, into great help for your research, but then also for teaching. If the prompt is written or designed appropriately to act as a set of flags, it is not just one single set of instructions, but rather it plants these flags at uh, all throughout the journey of the Gen AI to go from point A to point B, point A being your question, point B being the answer that you're looking for, so that the tool is not lost and you arrive at the answer you are looking for. So, before we jump into today's agenda of understanding or getting to know a handful of tools, so 1.5 hours is just for the introduction, I would say, and you would have enough opportunities to experiment with these tools on your own. Most of them have a very simple learning curve. They are easily accessible on the web, no download required, and all the tools do have, at least most of them, 90% of the tools that I'm mentioning today will have a free tier that you can access and check. Before we do that, it is important to establish certain ground rules. And one ground rule here is that AI is amazing, but this entire ecosystem is pretty complex. It is layered, and we do not understand all parts of this technology or its evolution. Even people who build the technology don't understand it completely, and that calls for a lot of caution alongside the curiosity that we have for this tool. On that note, I'm Dr. Saumya, and to add to the beautiful introduction from Professor, I do two things right now. One is being a speaker who gets to travel across India talking to wonderful faculty members across multiple institutions, from engineering colleges, medical colleges, pharmaceutical colleges, law colleges, to social sciences and environmental institutions. I have traveled through thanks to this interest across AI for research and teaching as well. And the second part of what I do has to do with a small team of editors, where we have a startup called Saumi's Pow. It is still in a startup stage, not a registered entity yet, but still our hands are full, where we offer private webinars, workshops. But then we also have this small team of editors who work majorly with pharmaceutical papers, medical sciences, life sciences papers, and so on, where we don't go straight. We are not a paper mill. We don't promise you publications, but we stand by your side to validate your manuscripts, to see where there are loopholes in your manuscript, to help you perfect the language in your manuscript, pick the right journal, follow the submission process, make sure that you address the reviewer comments appropriately, so that you have a better chance at getting your manuscripts published. Even when you work with us, manuscripts do get rejected, but then we are with you to go through the next process of submitting it to the second journal and so on, until the point that the manuscript actually gets published. So this puts me in a unique position where I get to train faculty researchers on how to use AI tools, but then also to actually interact with them as they are writing their papers, to understand the practical limitations in using AI, but then also the nice little ways in which AI can be leveraged in pretty ethical ways as well. So whatever I talk from this point comes from these experiences, comes from conversations with thousands of faculty members online and offline, and with hundreds of clients over the past 10 years or so, because we have been doing this even before AI. And I've tried to put together a simple journey from literature review to mock peer review, and one representative tool for each use case, which you can try to make sure that you have support throughout the process. So, when we talk about the first step of literature search and review, one quick experimentation that you could do is, instead of just sticking to Google Scholar for your initial searches, I would say start your search with a much more specific tool like Semantic Scholar. How is it different? So Semantic Scholar looks like Google Scholar. Same process. You go in, you give in keywords, and then the tool is going to bring back papers. This tool is completely free as well. One key difference is how the tool operates. Google Scholar focuses on keywords. So keyword A, keyword B, keyword C, It does not really focus, even when you throw in a sufficient amount of Boolean operators. Google Scholar still struggles to filter it down to relevant papers. The filtering process is not very stringent. Whereas on Semantic Scholar, it uses semantics, much more stringent process, which means if you throw in a set of keywords into Google Scholar on the normal search, I'm not talking about the advanced search, and when you throw in the same set of words into Semantic Scholar, on Semantic Scholar, instead of having the tens of thousands of papers that Google Scholar throws at you, if you're lucky, you just end up having a few hundred papers on Semantic Scholar. And also, it is not just about the numbers. These papers are much more relevant to whatever you are searching for, which means you have a better head start. You are not drowning in papers. You have good set of papers. You arrive at them pretty quickly, which helps you expand on your literature. Does this mean that I should not use Google Scholar? Not at all. Google Scholar is still one of the most versatile databases across multiple fields that is available. You should still go into Google Scholar at later stages to fill in gaps where necessary, but you can begin with Google Scholar to kind of speed up the process, I would say. Once you have a handful of papers, the next goal is to expand on literature. And when I'm talking about expanding literature, I already have 4 or 5 papers that I'm interested in, that I really like. Now, why should I go back to Google Scholar or to Semantic Scholar and keep looking for more and more papers that are maybe related or could be unrelated when I already know what I'm looking for? These 5 papers, great papers, and papers are not standalone entities. They have references, they have citations, which means there is already a well connected network of literature. And why am I not trying to find this literature? Why should I keep running back to Google Scholar and keep finding unrelated papers? Finding connected literature is what is going to complete my story. Now, this process where I have one paper or a handful of papers, and then I just look into the references, I try and map all the references, to try and map all the citations. Now, this process is called citation mining. This is something we do. We have never named the process, but this is how we have always been finding papers. This is a much more efficient way of expanding on your literature. And one good thing about this process is that this process is pretty straightforward. No creativity required, has a clear set of rules and instructions, which means when a process is well defined, when a process does not require creativity, does not require these intermittent human interventions, and AI can do a much better job than humans can do. And that is where tools like Litmaps, Research Rabbit, Insightful, Connected Papers, they come in handy for quickly finding connected literature. Have one paper, handful of papers, throw it into Litmaps. Litmaps quickly creates a literature map as you see on the screen. This is a collection of papers. Circles are papers. The lines are the direct citation links between multiple papers. Now, this is the first 20 papers highly related to this one paper that I picked. And right within the interface, I'll have the possibility to read the abstract and title, the original abstract, original title, and the tool allows me to take a decision of if I want to retain the paper or if I want it discarded, which means despite Litmaps being an AI tool, despite Litmaps going into Google Scholar and scourging for a set of papers and bringing me 20 papers, the final decision of what papers make it to my literature collection, it still stays with me. And also, this is one of the most ethical ways in which you can use AI for research, because here AI is not writing for you, AI is not making the decisions for you. AI is behaving like a proper assistant that does the job of skimming through a humongous library to help you find those 100, 200 papers that are most relevant to you. And the use of Litmaps will also not require ethical declaration when you are submitting your manuscript to the journal, because it does not breach ethics in any way. It is just Google Scholar better equipped to find papers for you. Now, Google Scholar, very lately, in the last few months, it introduced an AI feature called Scholar Labs. Now, this means you don't have to work on your Boolean operators or parentheses and all sorts of gymnastics. You go in, you ask a question, And based on the question, Google Scholar will give you just a handful of relevant papers. This is great. This would have been great and amazing had Google Scholar introduced this feature 3 years ago. Now it is too little, too late, because we have had amazing tools like Consensus that can do much more than what Google Scholar can do today, not last week or last month, but almost 3 years ago. So even before, at least 2.5 years or so ago, Consensus could, when was, yeah, Consensus has been around since 2023. That makes it a solid 3 years. Yes. So even then, you can walk into Consensus, ask a question. Consensus will give you an answer, a nice summary. It will also give you a consensus meter that tells you how literature leans in this particular topic. And then it gives you this nice, massive summary. Today, the summary is, this is a screenshot from 2 years ago. I just wanted to preserve history. But today, if you go into the live tool, the summary is much longer than this. It's much more exhaustive. And from then to now, every single key sentence has a citation. And not just citations, you can hover your mouse and you have a pop-up which will give me the title. Click on the title, I'm taken to the original journal page, which means I can validate every single point that has been mentioned here. Now, the question you should be asking me is, why should I use consensus? Why can't I simply use ChatGPT? ChatGPT can also give me the same kind of a uh, answer or the same kind of a briefing. Yes, it absolutely can, but you will have to prompt engineer. You will have to tell ChatGPT that you're trying to write a literature review, and then you want research papers to come from the past 3 years. It must come from journals of a certain quality and so on. But when you use tools built for academic writing or research writing, like Consensus, for instance, these conditions, these prompts are inbuilt as filters. Just apply the filters, go ahead, ask your question, simple one sentence question in natural language, and you get your answer. So once I have this answer, the next step I would look for is for a tool that will help me read across hundreds of papers quickly to find targeted information. The goal when I have this entire collection of literature is not to always read every single paper closely. That I would have to do, but at a later stage. In the initial stages, I'm just trying to classify papers, I'm just trying to understand what literature has to say, where this feature called a literature matrix becomes helpful. A literature matrix is nothing but it's a tabular column similar to what you will have on a Microsoft Excel sheet, where you can get specific information. So say I want to understand the research gap across hundreds of papers, add a column called research gap, and all the research gaps mentioned across these papers get populated into that one column. You want to understand the limitations, you want to understand the significance, just keep adding columns, and in the next 1 or 2 minutes, mostly under a minute, you have the information in a specific field or a specific column, making it easier for you to quickly understand information across papers of your choice. So you can upload your own literature collection and interact with these papers simultaneously, 100 papers simultaneously, by using these literature matrix option on elicit, on size space, on answer this, and so on. So good scientific writing comes from good results, from good writing, and also from making sure that you are doing the work at the right time. But for all of this to really work, good results can only come if your questions are really good enough. So one of the tools that you can use to validate your research question, once you identify a research gap, you can validate your research questions on multiple tools, but tools like Chat Academia are built specifically for validating research questions, which means they see if your question is unique enough, if it has all the necessary components to it, and then the tool also gives you suggestions as to how you can refine this question to or a geography specific question, so that your research question becomes unique enough with a better chance of your grant application being accepted. I would not start my work with AI tools when it comes to identifying questions, because these AI tools, sometimes they are just echo chambers where they just go back and forth with the same thoughts. But I would rather invest time in understanding a question, understanding a field, and then I would use these tools rather to validate the question. Now, when you talk about something as sensitive as a research question, it's important that you don't take anyone's word for granted. Always do your own due diligence to make sure this tool can be trusted in terms of its data privacy policies and earlier examples of data privacy breaches and so on. So all these tools we talked about in terms of finding literature or collecting information across papers, it all works as long as you're talking about a narrative review. But if you're talking about a systematic literature review, those tools do not work because SLRs come with their own set of rules. So are there AI tools that can help you collect within the limitations or within the rigor that systematic literature reviews demand? Yes, one of the simplest AI tools that you can check out is called Ryan. Ryan is what would help you collect papers, keep track of your literature, and when you work completely within Ryan in the decision making process, in the review process, then your Prisma diagram or the Prisma framework also gets generated automatically, which makes your life pretty simple. Ryan is just a very small platform, very minimalist platform, because you have tools like Covidence, for instance, which have much more features than Ryan. Covidence is not exactly free. You can check out many of its features for free when writing a systematic literature review and meta analysis. But when you really want to use it in a practical sense, you might have to go for the pro version of the tool. And this whole validity or the reason for writing an SLR kind of came into questioning a year or so ago when this tool called AutoSR demonstrated that it can complete a systematic literature review in a few hours. Normally, an SLR is going to take a few months, if not years, which some researchers do invest in writing a good SLR. So, this was replaced by AutoSR, which can do the job on par at the same level of results in just a few hours. And this, I'm talking about almost a year ago. And today, AI has definitely come a long way, which means this timeline is much more reduced. There are tools that can write or rather generate LRs that look like SLRs in a few minutes even. With all of this noise around AI tools, what we forget is sometimes not everything has to be AI. There could be non AI interfaces with AI plugins as and when necessary that can be equally useful. And one such interface that you should check out is called Obsidian. If you have used Notion, Notebook LM, Obsidian kind of falls under the same category as these tools for knowledge management systems, but Obsidian is also quite easier and it has a lot of features on the free version. So you don't have to really shell out money until you really want advanced plugins and features to use Obsidian. So when it comes to reading scientific papers, you need help in quickly understanding the um, background information of a paper, because papers don't always give you the basics. They don't always um, start with the basics. Just give me one moment.
Excuse me, ma'am. Sorry to disturb you. Your voice is not audible, ma'am. Ma'am. Acha.
Am I audible now?
Yes, ma'am.
Yeah, okay. I just stepped away because, yeah, I had a few bouts of cough. Okay. So when we talk about understanding or reading manuscripts, we need systems which will help us, especially for researchers who don't come from countries where English is our first language, to quickly understand overarching information. That is where tools like SciSpace, especially the Copilot feature, not just in SciSpace, Copilot features exist across multiple tools that help you understand papers easily. Like you can upload a paper, the PDF version of the paper, and you can quickly highlight sections that you don't understand. Highlight sections where you need more information to appreciate what is being said. And then these tools quickly expand on the information and help you find related papers, help you expand on the information, expand on definitions, quickly create glossary lists, and so on. Not just the way we read papers, the way we do the entire idea of reading can actually be reimagined with AI tools, because now with the availability of tools like Speechify and listening.io, you no longer have to really sit down and read a paper. Instead, you can just upload your paper to one of these tools and listen to the paper as you are doing everything else pretty much.
Ma'am, kindly give a minute. I will mute everyone.
Yeah. Okay.
Yes, ma'am. You can unmute yourself and continue with the session.
Okay. So all good?
Thank you. Yes, ma'am. Thank you.
So now with these tools, you can actually listen to the papers instead of having to sit down and read. At a time when all of us are really running, not a fan of multitasking, but when something has to be done, you just have to get it done, no matter how, right? So you can listen to your papers as you're driving to the institution, as you're cooking, as you're gardening, as you're hitting the gym, and whatnot. And you can also parallelly use these same tools to listen to your own writing. Or as a teacher, you can also use these tools to listen to your class notes if you are preparing for your next class and whatnot. So most of these tools, they are built for one purpose, but I'm sure researchers and in general, people have found multiple ways in which the same are built exclusively for summarizing, like scholars say. No matter what tool you are using for summarizing, it's important to understand that generating and summarizing are not really different in the eyes of AI content detectors, like Turnitin, for instance. So, if you generate AI content, that would still show up as 100% AI or at least 70-80% AI. If you upload a paper or your own notes into a tool and then summarize it using AI, summarized information will also turn up as 70-80% AI, which means you have to be very careful with AI generation, but also with AI summaries. With AI today, you don't have to sit down at a screen and type out your manuscripts. You can actually dictate your thoughts into a tool like Audio Pen, and these thoughts need not even be properly organized. They can be broken, they can have language issues, and tools like Audio Pen will sit down, they transcribe your voice notes into written content, typed out content, and then they do a good job of proofreading and rearranging sentences, filling in gaps where necessary, making them pretty useful when you want to be writing your papers or writing anything on the go. Now, there are copyright issues, there are ethical issues in using AI for writing. But when you use AI for creating images, the issues just compound, they become much more larger. And for this reason, despite the availability of multiple tools, Journals usually ask you to refrain from using AI generated images. But that is slowly changing. Journals are considering the possibility of using AI generated images as long as there has been human validation, and also that there are sufficient human inputs in creating these images. But for now, by and large, most journals don't want you to create any of these colorful, super creative images for your manuscripts because they don't simply fit. But you can still use hybrid tools like BioRender or MindyGraph for creating your images. These tools, they do have an AI component. MindyGraph does have a AI component to it, but they are still heavily template based image creation tools, and they work great in medical and pharmaceutical sciences, where anything and everything you need, all your components for the images are available as a library. You can open a canvas, pick and choose the components, literally arrange like how you would create a PowerPoint, for instance. Just that here you don't have to create a cell from scratch. You don't have to create an antibody structure from scratch. Antibody structures exist, cell structures exist. You just have to search for what you want and then just rearrange them and your image is complete. And when you're on the pro version or the paid version of BioRender, MindyGraph and the likes, then you own the copyright of the final image you create, which means there are no copyright issues. You have full right to the usage of the images. You can use them in your manuscripts, in your conference articles, in your thesis, in your presentation. Just make sure that you mention the tool that you used for creating the images. That is the only thing that is expected of you if you're on the paid version of these tools. A few other tools to try out when you want to create these illustrations include eDrawMax and Visme. So eDrawMax more for layered structure diagrams like flowcharts, flow diagrams, and Visme, one good application is where you can use it for quick data visualizations, not for statistical analysis per se. Visme cannot run an ANOVA, it cannot run a student t-test. But if you want to create a quick bar graph, a quick pie chart, a quick scatter plot, then that can happen with Visme. You can pick an output, upload your data, and your final output is ready. Now there is generating images for your in-text requirements, and then there is creating images for your graphical abstracts. So for now, the rules of AI almost remain similar between your in-text images and for graphical abstracts. At both places, the use of AI is kind of frowned upon, but graphical abstracts do have great tools in the making. Once journals have better policies, making graphical abstracts might become easier. But with the same set of tools that we talked about, be it Visme, eDrawMax, MindyGraph, or BioRender, all of these tools work great for creating your graphical abstracts as well. Now, how about statistical analysis, where you're talking about proper quantitative analysis, proper numerical data? There are tools like SPSS, which do a good job, but they do have a steep learning curve. That is where tools like Julius are gaining popularity, though they are not as versatile as your traditional statistical software. Julius makes it easy because talking to Julius, doing the analysis with Julius is as simple as talking to ChatGPT. Again, the question arises of why not ChatGPT, why Julius? Because Julius has kind of academic endorsements to it, and also it was built for working with academic research data, unlike ChatGPT, which is more of a general purpose tool. So with Julius, all you have to do is just log into the tool and then start a chat like you would start with ChatGPT. You can upload your data to Julius on your chat and then simply write a natural language question. Maybe you are not sure what kind of analysis has to be done. You can describe your data, ask Julius to um, suggest the statistical analysis that would be appropriate. Or once you know what statistical tool would be appropriate, you can just ask Julius to run an ANOVA on your data set. And then say once ANOVA is done, you would like to do a post hoc analysis, say run a Dunnett's test, for instance. you can just mention it in very clear, simple English language, and then the tool will go on to do the post hoc analysis. And then you want to say visualize the results. You just have to ask the tool, and it is visualized into a box plot or whatever is appropriate. So that is possible. But once you have very advanced requirements on statistical analysis, Julius might stumble a bit. But having said that, these tools, they are still beta testing. They are still working with a lot of different things. And maybe what is not possible with some of these tools today might really become possible in a few months down the line. I think this would be a good time for us to really pause, considering you have all been seated in a place, I believe. So let's take a 5-minute break. And this would also be a nice time for you to start posting questions if you have any. I would be happy to take them. I am unable to see the chat box. So if you have any questions, we can take a few questions, take a 5-minute break, take a walk around the block, and come back and continue.
Yes, ma'am.
So I don't see any questions in the chat box as such. So I think let's take that 5-minute break. So it's around 11:50. I'll see you at 11:55. Yeah.
Yes, ma'am. Meanwhile, we will gather questions, ma'am.
Yeah, sure.
Yeah, thank you.
So, hi, I'm back. Hope you are all as well.
Yes,
So,
ma'am.
I have two questions in the chat box. So, from Sirisha asks if there are any such tools in chemistry for identifying novelty of process and novelty of products. I really am not aware of such tools, but I'm pretty sure such tools are available. I have not really worked in this particular field, so I think it's more of my ignorance on the tools and not a lack of tool as such. I'm pretty sure you would be able to find these tools if you search enough. And to answer your question, Dr. Lavanya, I might not share the PPT as such, but I'll share the list of tools, additional tools that I'm mentioning as I go as well, so that that would be useful for you. So, tools to draw or generate chemical structures. BioRender can generate a few structures, but apart from that, I cannot really remember the name, but there are really good tools, AI tools specifically for creating these chemical structures. I just cannot remember the name from the top of my head at the moment. Yeah. So let me go back to sharing my screen. So my screen is visible and I'm audible enough. Does everything look good on your end?
Yes, ma'am.
Okay. So before the small break, we were talking about AI for managing quantitative data. So, how about qualitative data? If there is focus group data, interview data, and so on, what tools can really help me with that? So, one tool you can check out is Insight 7, built for corporate decision making majorly, but works well for other qualitative research content as well. Now, how about having AI tools for managing references? We exactly don't need an AI tool for managing references, at least so far, because there are good tools like Zotero, Mendeley, and Note, which have done this process efficiently. And they are in many ways better than the AI tools that we have at the moment for these use cases, because they offer a platform where you don't just store literature, you interact, you annotate, and then um, even connect literature between each other and also automate the citation and references. So my choice would still be Zotero. But if you are stuck in a place where you would need tools for just taking care of your reference lists for quick conversion, then I would say Trix is a costly choice, but worth giving a try. Now, how about tools that help with language? Can I use AI for language corrections? Can I use AI for proofreading, for paraphrasing, for rephrasing, restructuring? This is a tricky use case because, on one hand, this is a very legitimate use case because what if I'm a researcher from a country where English is not the first language, like India, for instance, where I have the research, I have the knowledge, my only limitation is my fluency in English. In such cases, usage of these tools must be really legitimate. But the problem is that it is not possible to differentiate between AI generated content and simply AI proofread or restructured content, which means because there are lack of tools to differentiate between the two, both have to be treated as the same. And for this reason, you can use tools like PaperPal for simple grammatical correction, simple proofreading, maybe sentence level changes. But when you use these tools for anything more than that, for any bulk changes, for major rephrasing or paraphrasing to say reduce plagiarism score or so on, then it becomes problematic. So I would not use these tools as such. And PaperPal is no longer just a language editing tool. It has AI writing features, reviewing features, and with its whole package of tools offered under the researcher.life portfolio, there is much more that PaperPal can do. Now, how about writing with AI tools? How about brainstorming with AI tools like Jenny, for instance? Jenny is one of the oldest, I think, earliest tools that came up with this complete AI writing. Today, so many other tools can do this. Edicit can do it. Consensus, not so much, but SciSpace can do it. Answer This has the possibility. Paperpal has a writing feature. So no matter what tool we are talking about, AI writing is still tricky. If you let AI create the outline for you, if you let AI develop the argument for you, then who actually owns these ideas? How does it make you the researcher? How can you put your name as the first author on a paper that was ideated by an AI, was written partially by an AI as well? So the ethical lines when it comes to using AI for writing, AI for even brainstorming and uh, generating ideas for research, it's a very thin line. It's a lot of gray area there. So I would really tread pretty carefully. How about using AI for formatting manuscripts as required by the journal guidelines? One tool that had this even before the AI revolution was Typeset, and today Typeset is what has evolved into SciSpace. Even back then, they had template-based formatting options. Today, SciSpace does have formatting options within its agentic AI portfolio. This is a very legitimate use case where you can use AI. The problem is, can it be as accurate as a human editor? It's still slightly questionable. So most of the formatting tools that we talk about, they work within the MS Word interface. But what if I'm not using Word? What if I'm working on latex applications like Overleaf? So one tool that could work within Overleaf is Einsia. So if that is your writing platform, then maybe you could try this as your research assistant as well. Once the manuscript is written, there are a lot of checks that have to be done. Like, for instance, the title page, the language, the cross verification of your references and citations, your citations for your figures and many more have to happen. The inclusion of declarations, inclusion of page numbers, and PaperPal has this small tool called Manuscript Check, a feature exactly that can check your manuscript for close to 30 different aspects. Now, this is a generic search. So it is a generic check. So where it only checks generically. This check is not specific to a journal. So you can run this check, quickly see if your manuscript has all the different components, but still cross-checking with the journal checklist would be essential. Now, peer review.
Ma'am, kindly give a minute. I will mute everyone. Yes, ma'am.
Yeah.
Thank you.
So peer review is, once you submit the manuscript, peer review is one of the costliest things that you have to go through, not in terms of money, but in terms of time. Because an average peer review will take at least around 3 months, which means if your paper has to go through 3, 4 rounds of peer review, that is easily 1 year wasted in peer review. How can we do this better? How can we reduce the timeline? The answer is simple: submit a better paper. But how do I submit a better paper if I do not know what the peer reviewers would ask for? That is where tools like Paper Wizard can come in handy, where these tools can give you a mock peer review. You finish your paper, and before even you submit to the journal, you can submit it into these peer reviewing tools like Paper Wizard, which will give you a detailed feedback on what is good, what doesn't work with your paper. This will allow you to make necessary changes even before you submit to the journal. That way, you have a great paper initially, which makes it easier for the peer review process. So, say the length of your peer review is reduced by 1 round, then that is still a good amount of time saved between your submission and your publication. Now, unlike the other tools, all the earlier tools we talked about, the major limitation was um, AI content. So if I use a tool, will the tool introduce AI content into my manuscript? That was the concern. But with these last set of tools, like the manuscript check or a mock peer review or the tool for formatting your manuscript, the major concern is data privacy. So one question you have to ask here is, because these tools don't make any changes to the content of your manuscript, therefore they do not introduce AI content. But will using these tools compromise the uh, privacy or compromise the data on my manuscript? Will these tools use my data for testing their models, for training their models? For this, don't take anyone's word for granted. Though I have handpicked tools that have had really good reputation over the years, I would still urge you to do your own homework before you decide to use any of these tools, where you hand over your own manuscripts, completed manuscripts, into these tools. Now, how about grant writing? Are there tools that can help me with writing my grant proposals? All the tools we talked about up until this point, the same set of tools can be used for grant writing as well. A proposal is not much different from a manuscript, just that a proposal gets written before the work and a manuscript gets written after the work. Apart from that, the rigor that is required, the processes required are almost similar, which means all these tools can work for grant writing as well. What we ideally want is a tool like Atom, which works nicely in the US ecosystem, where we have this one stop platform which will have a collection of grants where you can write your grant proposal, and the AI will match your grant proposal to an appropriate open grant and help you submit the application, and in some cases also help you with the post award management of the grant as well. Right now, we don't have a similar system for the Indian ecosystem, but let's hope it happens sometime in the future. Now, how about using AI for making presentations? This rule applies not just for presentations, but for any AI tool in general, I would say. Any AI tool works great in the hand of an expert or a semi expert, people who already have the base knowledge of the field, people who already know what they are looking for. And they have a certain amount of knowledge to do a basic validation of the output. Now, if that is the case, tools like Dectopus, Gamma, Beautiful AI, all of these presentation making tools, they work great. You walk in, you can use the prompting option to get a complete 5 slide, 10 slide deck, or you can upload your own PPT, improve on it. You can upload your notes, and then you can convert your notes into a PPT. Now, converting notes into PPT is the most valid way in which these tools can be used, because the content still belongs to you. You're just outsourcing the aesthetics, color combinations, fonts, shapes, sizes. This is something we don't really have to always focus on. Not everyone is good at that. We don't have to really do that as well. So that outsourcing is perfectly fine. And using these tools to quickly chip in and fill in certain gaps is also okay, provided you know your topic in and out, and you're using the tools just for aesthetic, just for creating a prop, and not for exactly creating or generating your entire speech. Now, good talks are never about PPTs, never about what is on the screen. It is always about what is before the screen, the person who talks. It's all about what they bring to the table. How curious can they make you? So, how can you become a better speaker? Because in academia, speaking is a non negotiable. You will have to walk up to the dais and present at least a month or so. So, are there AI tools that can help me hone my speaking skills? Yes, you have tools like Poised, which were built for mock interviews, but can also work for your research presentations, where you present your work and the tool gives you feedback and you work on making your presentation better. No matter how many tools we talk about, at the end of the day, one question persists. This is so overwhelming. There are so many tools. I cannot really subscribe to so many tools or even manage so many tools during my work. Is there one tool that can do many of these jobs together? A few months back, we did not have an answer to that question. But today, the answer we are looking for are agentic AI tools. Say, for instance, the SciSpace agentic AI can do your literature review, can help you with your literature review, help you with your writing. It can create images. It can do a bit of statistical analysis. It can create your posters. It can answer a lot many questions and do very complex processes as well. But what is the catch? The catch is that the cost difference. The economy is the first limitation that we will have. A standalone tool before agentic AI might have cost you 500, 700 rupees per month on subscription. But the agentic AI enabled size based subscription will cost you somewhere around 5,000 rupees every month. So that's a 10x increase in cost for every single month. What costed you like 50, 60,000 in a year would now easily cost you 10x more, 50, 60. Sorry, say 5,000, 7,000 would now cost you 50,000 or. But if you do have such intense use cases, this definitely is worth a try. Now, when it comes to ethical questions, one thing is clear: you cannot use AI to the extent that AI becomes a co author. Journals don't allow you to add AI as a co author on your paper as well. But that is today's stance. Going down the lane, this might change. Ethics are always dynamic, and this would boil down more to policies and politics than to actual ethics. And with respect to journal rules, so journals are usually okay with you using AI for ideation to a certain extent, for language corrections, grammatical corrections, minor sentence level corrections. Beyond that, when you use AI, you are expected to proofread the manuscript, you are expected to vet the output, and the human authors will always be held responsible for the entire content of the manuscript, just like always. Now, because you used an AI tool at certain respects, you will not be able to outsource the responsibility to the AI. You still will be held responsible for everything on your manuscript, just like always. And just like always, the corresponding author will shoulder the majority of the responsibilities. So it's on the shoulders of corresponding authors to ensure that AI is used minimally, AI is used where it is appropriate, and in all other cases, AI use is declared openly, transparently, and then let the editors decide. Now comes this problem of tackling AI content detectors. This has been a nightmare because content detectors are not accurate. They cannot differentiate between human and AI writing because AI learned to write from humans. But we don't have a better system. Publications as an industry is suffering. They don't have choices. They don't have better ideas of how to exactly overcome this threat of completely AI generated papers. And for that reason, AI content detectors are staying inventory. But that does not make them good, that does not make them useful. They are actually counterproductive. But until we develop better systems, until journals change their policies, you will have to check your manuscript for AI content as well before submission to ensure your paper gets accepted. Now, if AI content detectors are not accurate, can I use humanizers to humanize my text? No, that does not help. Maybe humanizing would reduce the AI content by certain numbers. Maybe a good humanizer, multiple rounds of humanizing, might be able to cheat a content detector. But what does it do to your paper? So, what exactly is the goal of writing a manuscript? It is not to be playing these losing games with content detectors and humanizers, but rather to communicate a valuable research to the community. And that core essence will be lost because humanizers kind of mangle up the language. They don't care about retaining the integrity of the concept or the language. They're just focused on cheating on content detectors, which is not a good goal for any writing tool. So I wouldn't use humanizers. I wouldn't use them as a student, as a faculty. And similarly for AI content detectors, I would not rely on them if I were a faculty to assess if my students are using AI. I would rather redesign my assessment. I would rather redesign my classrooms. So, talking about redesigning classrooms and AI for teaching, how can AI help in teaching process? So, this is just a small set of tools. I've kept it minimum at the moment. So, one place where you can start, one tool you can start with experimenting is called eduaid.ai. This is a tool where you have inbuilt options, inbuilt prompting capabilities, right from creating lesson plans, creating lesson content, gamifying your classroom, and it also helps with certain extent to your assessments as well. So this is a good start to start experimenting with AI as a teacher, as a faculty in the higher education ecosystem, to kind of lighten your burden with respect to preparing for the classrooms. But the same set of rules always apply. You own the content comes from you, you validate it, and you change it as per your style. Now, how about if you want to take this one step further and then kind of create recorded content, recorded resources for your classroom? That could be played in your classroom, that could be safely offloaded onto a YouTube channel or into a LMS that you are trying to develop. Then DID is a great platform to check out for creating these interactive videos and AI avatars. When it comes to assessing the student uh, attention in a classroom, or to assess them in a formative way, we all learned during the COVID times that Kahoot can be really helpful. The gamification around learning really brought in many students to finish the quizzes and so on. And quizzes is a tool that took the Kahoot model and then made it way, way better. And recently, quizzes was rebranded as Wayground, Way, GROUND, Ground, and the features remain pretty much similar. And this could be a nice platform where you can have a flipped classroom model, where you're not teaching just delivering knowledge in your classroom, but rather you're using your classroom as an assessment platform, or you can also use this to create exit quizzes for each of your lessons to ensure that there was sufficient attention during the classroom, to also see which classes don't fare much, and also to see which students really do not pay attention during the classrooms or have difficulties in grasping what is being presented to them. And quizzes, the outcomes could also be a part of your formative assessments, maybe not completely replace formative assessments, but a good percentage of formative assessments can actually be reimagined as well. If you are looking for Indian made solutions that work well in the Indian context, Eclavia is a tool that you can. Eclavia is not a tool exactly, it's a collection of resources, a company that you can definitely check out to see if their assessment features, their assessment offerings really align with the requirements of your classrooms and your institutions. One thing to remember when it comes to using AI in classrooms is that the goal here is not to replace our teachers. It's not to automate the classrooms or to automate the um, teaching learning process, but rather to augment the process. We still need the classrooms to be led by human teachers, but we want to lighten the load of these human teachers by offering them the assistance of these AI tools, because a teacher brings much more than just knowledge delivery to the classroom. And now, just because the knowledge delivery systems are changing doesn't mean we will have to replace our teachers with AI, but rather help them do better, help them do it with much lesser stress, I would say. Now, this question has become almost redundant because students, today's Gen Zs, mostly in the higher ed ecosystems, they are not asking anyone's permission to use AI. They are already using AI. They are the digital generation that know how to use these tools much better than the previous generation sometimes. Now, the goal is not to penalize students for using AI, because AI is the talk of the day. AI is changing job opportunities. AI is changing everything around us in the world, which means students have to be prepared to walk into a world with AI, find jobs, still stay relevant, and still find sustenance, which means they have to be taught AI. They should be given free hand in using AI, just not in every single assessment. Maybe you have 4 to 5 assessments in a semester for a paper. For 4 assessments, stick to your traditional ground rules. But for one assessment, you can open up the assessment, you can give them free hand to see how they fare when they are allowed to use AI. And this will also require that you redesign your assessments. It cannot be simply writing an essay using an AI tool. It has to be a multi step project. You should think in terms of level up projects. You should think in terms of assessing the process, which again might be sometimes difficult. So when it comes to using AI for assessments or allowing students to use AI within classrooms, beyond classrooms, it is not just a case of introducing a few tools. It's more a case of developing proper frameworks, developing proper AI literacy benchmarks to ensure that AI is opened up, the world of AI is opened up to students legitimately. They don't have to hide behind shame because they used AI, but then also making sure that they do not get lazy and outsource everything else to AI. This is going to need a lot of groundwork. It's going to need a lot of reimagining. And this happens to be one of my favorite things to do at the moment. Sit in a classroom with a handful of teachers who come from different fields and actually figure out what could be possible assessment modalities to ensure that students have access to AI, but they still have to learn a certain skill or they still have to pass a certain benchmark, even with the help of AI, to actually go beyond the course. It's not easy, but then it's also a pretty interesting field to work. And one other place I love to be is on policy tables, where students also be a part of these tables to evolve AI policies at the institutional level, at the classroom levels, because we have reached that stage. Without policies, we cannot move forward. So, if you don't have a AI policy committee, high time that you kind of form one, and then you bring in different stakeholders, have a lot of conversations with ideas that this policy document is not going to stay stable. What you make as a policy this month might have to be amended in the next 2 months or so, because that's how AI is developing, how fast AI is, and we'll have to catch up to it, but that has to happen nevertheless. So there is this really nice story in Greek mythology that talks about the origin of fire. And it says that there was this young god called Prometheus who was very fond of humans. And this was at a time when fire did not walk on earth yet, it belonged only to the gods. Prometheus, because of his fondness for humans, he thinks, if I give fire to humans, maybe their lives would be easier. And one fine day, he flies down with a bunch of or a bowl of fire in his hands. And Greek mythology believes this is how fire came to be on the earth. I'm not sure how true this is. But I'm pretty sure that when fire was discovered for the first time, not all humans were happy. Some humans, the optimists, they must have thought, wow, this is a great discovery. Now we can cook our food, we can keep ourselves warm, travel in the dark, protect ourselves against the animals. But there definitely would have been handful of pessimists who saw the dangers with fire. They saw that this burning, blazing thing could destroy forests, could destroy animals, could destroy humans, could destroy Earth as humans knew it back then. Now, who was right? Both of them were right. Thanks to the optimists, we still have fire. They did not let the fire die out. They made sure that fire was passed on from one generation to the other despite its dangers. But thanks to the pessimists, the naysayers who don't want fire to destroy the earth, we have fire that is much safer. Even today, there are forest fires happening. Buildings catch fire. There are so many fire accidents around us, but majorly in our everyday use, fire has become safe because of the pessimists. So it is important that we listen to both these categories of people. Yes, be very excited, be very curious about AI, but then also be cautious, because as much as AI can give, AI can also take away so much from us. And at the end of the day, it is never about technology. Technology is neutral, it just stays as a tool. How we use technology, how politics designs technology, how policies define what technology can do within classrooms, within the research ecosystem, that is what will determine if a technology is really beneficial or does it cause more harm than good. And being in a very pivotal position where we are the humans, we are the adults taking these decisions, I just hope we take better decisions. On that note, thank you for your attention. And this is where you can reach me beyond the session as well. This takes you to my LinkedIn page. I'll also share it in the share a link in the chat box where we can stay connected. And when I'm not traveling for sessions, I write about AI tools both for research and teaching, and also the ethics of using AI in both of these fields. I like curating sets of tools. I like reviewing new tools and new features to existing tools that make research and teaching slightly easier. I'm not great with calls, but I'm great with WhatsApp. So if you want to reach me, you can just drop me a WhatsApp text and I'll get back to you in a few hours to set up a call. And if anytime you are looking for support with your manuscripts, you can always drop us an email. I don't have to be available. Someone from the team will take up your request to help you get through your manuscript publication journey. Now, this QR code is where you can submit your feedback that comes directly to me. And this will help me understand your requirements when it comes to AI tools for research and teaching. And when you submit this, you also get a PDF version of close to 30 tools or so, which will be a ready reference helping you uh, have it with you always. So just give me a moment. I'll share these as links so that it gets better. So you'll find the feedback link, LinkedIn, and my contact details so that you can reach me anytime. I'm just going through the questions. If you have any further questions, you can just drop it into the chat box. Or if you can unmute, you could do that as well. So I'm just taking up the question from Dr. Akshay at the moment. So privacy, I think I did talk about the privacy with respect to certain tools where you given your private sensitive data and so on. Even otherwise, if a data or information is really sensitive, I would say mask the data before you start using these tools. So if the idea is too novel to trust a tool, just do not use the tool is what I would advise. Though most of these tools, they have not had one case of data breach complaint against them in the past 3 years or so. But just to be safe, you can still withhold sensitive information, mask the information, and then work with the tools. I don't see any further questions. If you have questions, you can just drop them into the chat box.
Thank you, ma'am, for your explanation. You have guided us how to write a paper and what are the online apps available to write the paper and to draft the, and also you guide us how to do an article meta-analysis and systemic reviews. Thank you for your explanation, ma'am. Now we are into the QA session. If any questions from the audience, please post it in the chat group. Madam will answer the questions.
Or if you want to unmute yourself, you could do that as well, I believe.
If you can raise the hand, we will unmute you. Any questions? ఇప్పుడు ఎలాగా? Thank you, ma'am. Now we come to the end of the QA session. Over to you, Mrunalini, ma'am.
Unmute. Thank you, ma'am, for the insightful session generative AI in scientific writing and teaching methodologies. For the benefit of all the participants, we kindly request you to share the details of the AI tools, presentation tools, or any learning resources during the session, as they greatly support us for our future learning and professional development.
Sure.
Thank you once again for your time, expertise, and valuable contribution to the success of FTP. Thank you, ma'am. As we reach the conclusion of this 5-day online faculty development program on AI and data science in pharmacy education, teaching strategies and practical application, it gives me great pleasure to reflect on the remarkable learning journey we have shared together. Before we conclude, I would like to express our heartfelt gratitude to our respected Professor A. Sunita Madam, Principal and Head of the institution, for her constant encouragement, guidance, and unwavering support in organizing this FTP. Ma'am, we are especially grateful to you for suggesting such highly relevant and contemporary topics for this FDP. I now request Professor A. Sunita Madam to kindly deliver the valedictory address.
Thank you, Mrinalini.
Thank you, ma'am.
Yeah. Respected resource person, Dr. Soumya Rani Garu, eminent faculty members, research scholars, and dear participants. As we come to the conclusion of this enriching 1 week faculty development program on AI and data science in pharmacy education, teaching strategies and practical applications, conducted from 2nd June 2026 to 6th June 2026 and organized by the Department of Pharmaceutical Analysis, KVSR Siddhartha College of Pharmaceutical Sciences, Vijayawada. I would like to express my sincere gratitude to everyone who contributed to its success. Over the past 5 days, we have explored the transformative role of artificial intelligence and data science in pharmaceutical education and practice. The insightful lectures, engaging discussions, hands-on sessions, and practical demonstrations have provided us with valuable knowledge and skills that will help us adapt to the rapidly evolving educational and healthcare landscape. I extend our heartfelt thanks to all the eminent speakers and experts who generously shared their expertise, experience, and vision. Their contributions have inspired us to embrace innovative teaching methodologies and leverage emerging technologies for enhanced learning, research, and patient care. I also congratulate all the participants for their enthusiastic involvement, active interactions, and commitment to professional development throughout the program. Your engagement has made this FDP a truly collaborative and meaningful learning experience. A special word of appreciation goes to the organizing committee, faculty members of Department of Pharmaceutical Analysis, program coordinator Dr. M. Vijayalashmi, moderators Ms. Mrudalini, Mrs. K. Jyoti, and all other faculty members of Kvsrscops for their involvement and commitment towards the successful completion of this FDP. A special word of appreciation to the technical team and supporting staff for their meticulous planning and tireless efforts in ensuring the smooth conduct of every session. I hope everyone will carry forward the knowledge gained, continue to explore new possibilities in AI and data science, and work collectively towards advancing pharmacy education and research excellence. Thank you all for your participation and support. Wishing everyone continued success in their academic and professional endeavors. Thank you for giving me this opportunity. Thank you, one and all.
Thank you, ma'am. Your continuous support and motivation has been very useful and guiding us in every way. Thank you for your valedictory address. On behalf of Department of Pharmaceutical Analysis, I would like to propose my vote of thanks to all our esteemed resource persons, Dr. D. Lakshmi Madam, Lakshmi Garu, MS Mallika Garu, Mr. EVS Garu, Dr. Harika Sabineni Garu, Dr. Prakash Muthu Garu, and Dr. K.S. Soumyarani Garu for generously sharing their expertise and experiences with us. It is particularly gratifying to note that many participants share their appreciation for the FDP, mentioning that the topics covered were highly useful, contemporary, and directly relevant to their teaching, research, and professional development. Such positive feedback is a true reflection of the success and impact of this program. Thank you, dear participants, for this positive feedback. And I also request all the participants to stay connected through the official WhatsApp group, where all further updates regarding the links or the any materials that are shared by the speakers, and regarding the certificates, and all the information will be shared through you through the WhatsApp group. Once again, thank you all for being a part of this enriching journey. We wish you continued success in your academic and professional endeavors. Thank you all.